In this lecture, we will begin the examination of the data frame, the most widely used Pandas object. The plan for the next few lectures is to cover the following topics: introduce the Panda data frame object and discuss its purpose. Create several data frames from scratch to reinforce your understanding of the concept from a programming perspective. Relate what you have already learned to what's written in the Pandas documentation. All right, let's take the first step to completing the list. So far, we've only mentioned the data frame as we were introducing the other key data structure in Pandas, series. It is time that we further elaborated the concept of the data frame. This is important because you will be constantly working with this structure while pre-processing and analyzing data with Pandas. In fact, it will be very convenient to develop an understanding of the data frame by comparing it to the characteristics of the series object. You are already aware of the latter, so let's take advantage of that. You can think of the series object as a single column data, or a set of values that correspond to a single variable, right? Well, the same can be true for a data frame, but more often relates to a multi-column data, where each column represents a different variable. That's why every column can contain data of its own type, and this is one of the best features of this structure. In other words, the information in a data frame can potentially be heterogeneous. It doesn't need to be of a single type, as is the case with a series. Nevertheless, this allows us to still preserve data consistency. We should keep aiming for having information of the same type within a certain column. Therefore, it is very important to remember the following throughout the lecture and beyond. Fundamentally, from the perspective of Pandas, the data frame is nothing but a collection of multiple series objects. This means that as a structure, the series corresponds to a single column of a data frame. So any characteristic of a series you can think of is also applicable to the separate columns of a data frame. Therefore, you can refer to the series object as a one-dimensional data structure because it contains values along a single axis, representing a certain number of rows. The data frame, instead, is a two-dimensional structure, in the sense that its data has been organized not only into rows, but also into columns. Thus, it represents a tabular structure and is the closest Python analog we can have to a standard two-dimensional dataset, so to speak, or a spreadsheet. So, a data frame can be regarded as a collection of series in the same way in which an Excel spreadsheet is a collection of multiple columns. That's why a data frame can have both row and column labels. All right. On the whole, how can such organization improve your analysis? Well, it frees you from constantly referring to the data frame as a two-dimensional NumPy array or a 2D matrix. Rather, you can think of it analytically as a collection of multiple observations for the given variables. Thus, you will be able to obtain information contained in a single data point by referring to the relevant observation of a certain variable. In technical comparison, you can use the row index of a series as a single point of reference to obtain a certain data value. While working with the data frame, though, we need to use 2 points of reference, the row index and the column index. If you use just 1 point of reference in a data frame, you'd obtain either an entire row or an entire column. To obtain the value of a single data point from a data frame, corresponding to the value of a specific observation from a given variable, you'll need the intersection defined by the relevant index and column positions. As a final juxtaposition between the two key Pandas data structures, let's view them as programming objects. Basically, the series can be looked at as a powerful version of the Python list. However, it also includes some Python dictionary features. For instance, a series doesn't just take integer, float, string, or other values. Its indexing relates to the functionality of the keys of a dictionary. Then, the related features of the structure can lead to many analytical inferences. Perhaps the most important feature is the advanced type of indexing associated with the series object, as opposed to the Python list object. The former allows us to extract the desired parts of the given dataset more quickly and efficiently. Taking that into account, the data frame object is essentially an enhanced Python dictionary. Much like creating a series from a Python dictionary, we can construct a data frame. The difference is that we don't need to associate just a single value to the dictionary keys. We can provide a whole object that contains the values of an entire column. Thus, the Pandas data frame provides dictionary-like access to its elements, inherits the characteristics of the dictionary class in Python, and adds a lot more features and functionalities on top to enrich the outcome of our analyses. Great! In this lecture, we covered the first point of our initial plan. We introduced the concept of using the Pandas data frame and compared it to the series object. In the next lecture, we will apply this knowledge into practice. Thank you for watching.